Welcome! In this video, we will build an intuitive picture of a network interface controller, often called a NIC. A network interface controller is the hardware that lets a computer talk on a network. It lives at the physical layer and the data link layer, turning bits in memory into electrical or radio signals and back again. Let's start with a simple picture. On the left, we have a computer. On the right, we have a network switch and the cable in between. Inside the computer is the NIC. The NIC sits between the CPU and memory on one side, and the network port on the other. It moves data to and from the wire, applying link layer rules along the way. Those tiny lights on the port indicate link status and activity, link up or down, and data blinking. Where does the NIC live in the OSI model? The NIC implements the bottom two layers. Layer 1, the physical layer, and Layer 2, the data link layer. Physical layer deals with voltages, timing, connectors, and radio for wireless. Data link layer deals with frames, MAC addressing, and error detection like frame checks. The NIC sends and receives frames. Here is a simple Ethernet frame layout. It begins with the destination MAC address, then the source MAC address, a type field, the payload that often carries an IP packet, and finally a frame check sequence for error detection. A MAC address is a hardware identifier like 3I9EFF2C7BE144. Now, let's animate a frame, leaving the NIC and traveling over the cable. We bring back our diagram. The NIC wraps data into a frame and launches it across the wire to the switch. Modern NICs can negotiate link speed and duplex with the switch. Common wired speeds include 10, 100, 1000, 2.5 gigabit, and 10 gigabit. During auto-negotiation, the NIC and the switch agree on the best shared mode. Full duplex means send and receive at the same time on separate lanes, while half duplex means taking turns and risking collisions. To relieve the CPU, NICs often perform offloads. Examples include checksum offload for TCP and IP, segmentation offload to split large blocks into frames, and receive side scaling to distribute incoming traffic across CPU cores. A wireless NIC does the same job, but uses radio waves instead of copper. It still handles physical and data link layers, now with wireless standards like Wi-Fi. In practice, to work with a NIC, you will check 3 things. 1. Link speed and duplex. 2. MAC address and configuration. 3. Counters like receive errors or frame check failures. To summarize, the network interface controller bridges your computer to the network, implements physical and data link layers, uses frames with MAC addressing and error checks, negotiates speed and duplex, and offloads work to keep the CPU free.